If you've been following along with this project and you've seen this development board in some of the videos, you will have noticed that we've really only used a couple of these connections. The development board has been invaluable for this project so far since we can swap out connections, but now that we've got a pretty good idea of what we're going to connect to and what content we'll be using from the microcontroller, we can start to strip out the unneeded components and connections so that we can shrink this board down into an eventually very small circuit board that will fit inside of our housing. We haven't gotten that far yet, but we know it'll be small. But what content is that? What do we need to keep from this development board, and what can we toss out? We're going to head over to our whiteboard and hash out all the details. Okay, so at the heart of our project is the microcontroller. So let's draw this. This is our Ep5.1. And we're going to have a slight configuration difference between the controller and the console. So let's draw the controller side first. There will be slightly more content. Okay. So our circuit has to get powered somehow, and we're going to be doing that with a battery. So this is going to be a AAA battery. That's 1.5 volts. 1.5 volts is not enough to power this microcontroller, so we need to step up the voltage, and we're going to do that with a circuit element called a boost converter, which is a sort of power supply topology which takes a lower voltage and boosts it up to a higher voltage. So in this case, we need to boost it up to 3.3 volts because that is the voltage that our console side runs on and that our controller is expecting. Okay, so that's going to feed into our microcontroller. Now, anytime we have a battery in a product, usually there's a risk that the user is going to put it in backwards, even if you have clearly indicated which orientation the battery should go in. So in order to avoid damaging the circuit, if someone does turn it around and plug it in incorrectly, we need some reverse battery protection. And we can do that with a device called a MOSFET, which is basically an electrical switch. So one leg is going to go here, and then the other one goes to our circuit ground. And then everything else is going to connect to the circuit ground. So this is the BAT plus, and this is the BAT minus connection. And then this is ground. Ground is just another way to say 0 volts in this instance. We'll simplify it. Okay. And a MOSFET is basically just a switch that's electrically controlled. And so in this case, when our battery is applying a positive voltage to this gate of the MOSFET, then it turns on and allows current to flow through. But if we end up with a reverse battery situation where we've got a plus here and a minus here, where we've got a positive voltage here and a negative voltage here, then that will stop the flow of current going this direction. So that's going to be our reverse battery protection. So we've got our microcontroller and our power supply. So we're powered. What is this microcontroller going to connect to? So we need, we've got the N64 controller with its 3 pins. So one of the pins is power, 3.3 volts. One pin is ground. And then the other pin is our N64 data pin. So this is going to be bidirectional. Okay, data. In addition to that, we will also have a button that we can use for pairing and for wake up. So we have a little push switch button here, and that is going to be connected to ground, and internally it'll be pulled up to some voltage. So 3.3 volts. So when the user presses this button, then we're going to be reading this pin at all times, and the microcontroller will be able to tell when the voltage on this pin goes low. The Nintendo 64 controller will consume quite a bit of current, so we don't want it to be powered on at all times, because that would drain our battery unnecessarily. So what we need is, similar to our reverse battery protection, we need another switch that will provide power to our controller only when we want it. So this will be some output. We'll call it power control. One thing that we'll need that we haven't really discussed yet is an indicator to tell us different states about our device. So I would like to include an LED and that will be able to shine different colors. So it's going to be an RGB LED, red, green, blue, and that can indicate some different things for us. So for example, if the battery is low, it will shine, it will blink red. If the device is paired with one of the console devices, then it will show the same color as the console device's LED. If it's not paired, or if it's in a pairing mode, maybe it will blink white. So anyways, we have this provision here for this LED that we can use. And how do we turn it on? Sometimes you can connect an LED directly to a pin, but in this case, what we will need is a switch similar to our other MOSFETs, an electrically controlled switch. So that basically we can turn this on with the microcontroller's pin, which can't actually supply that much current as this LED would need to illuminate. So we'll turn it on with a switch. In order to tell when the battery is drained, we will need to measure it, and so we will take this battery signal and feed it into the analog to digital converter, and then we'll be able to read this battery voltage and say nominally a battery is at 1.5 volts, but once it gets down to 1 volt or a little bit less, it's essentially all used up. So somewhere between 1.5 and 1 volt, we'll need to make the determination of when to indicate to the user that the battery needs to be replaced. Okay, so that looks pretty good. I think we're in good shape there, and we can come back if we think of anything else. Let's go on to the console side. The console side will be easier. So the console side is powered directly from the Nintendo 64. So we don't need the battery. We don't need the boost converter. We don't need reverse battery protection, since there's no possible way to accidentally plug in the console device incorrectly. And since we are not running on batteries, we will not really care if this microcontroller is powered at all times. So we don't need this. We can just feed the 3.3 volts directly to the microcontroller and have it powered at all times. Whenever the console is on, the console device is on. We still want an LED so that we can illuminate different things, like if the console is paired with another device or if it's in a pairing mode. And then we want the button to be able to activate this pairing mode. One last thing I thought of, I don't want to have two separate softwares to flash to these. We need some way for the microcontroller to be able to tell if it's a controller device or a console device. And usually how we can do that is by adding an external component, a resistor that is connected either to the ground node or to the 3.3 volt node. We can do something like that, and then we can decide a little bit later if we want it to be pulled up or down. And so then on the opposite one, console side, we would connect that same pin to the opposite direction. So if the controller device is pulled up to 3.3 volts on that pin, then the console device will want that same pin to be pulled down to ground on that pin. So at startup, when the software is executing, we'll go ahead and read this pin and see which device we will be, and that will change the functioning of the device. All right, now that we've got a basic idea of what content we've got in this circuit, we are going to hop over and start turning this into a circuit board. So I originally intended to make one video for the whole process of going from an idea all the way to a finished PCB. But I realized along the way that it would be a really, really long video as I started editing. So I'm going to chop this up into a mini series within our series of going from the concept to the PCB. This episode was just the concept, the block diagram. We're going to have another video dedicated to making the schematic, and then another video after that for converting a schematic to a PCB and assembling the PCB. So stay tuned for the next episode in the mini-series on the electronics. See you in the next one.